Good to meet everybody. We're going to get started on this tutorial to better understand how we can use CryoCloud to do all of our computing this week. If you want to find the slides that I'll be going through, it's on the PACE Hack Week Jupyter book under the tutorials. You can click here on the eyeball, that's the slides. You can also capture the QR code once this opens. And there's a number of ways you can access it. The link's right here. Yeah, so as Anna mentioned, I'm Tasha Snow. I'm a research scientist at NASA Goddard, just started there, and at ESSEC at the University of Maryland, but I'm remote. In a past life, or lots of past lives, I was a plankton or phytoplankton ecologist as an undergrad. I was a paleoceanographer in my master's, and now I do glacier ocean research. So most of my PhD was using thermal infrared to look at ice-ocean interactions around Greenland and Antarctica, and I produced an algorithm for creating sea surface temperatures from Landsat thermal. But I work with a number of satellite missions now. But yeah, I have a very interdisciplinary background. I was also an officer in the United States Navy, so if you have any questions about any of that, I'm happy to talk about it. We're going to be talking about CryoCloud. The name is deceiving. Please do not let it put you off. One of our proposals was to create a place for researchers in the cryosphere to be able to access the cloud, but we have multiple proposals in now to rebrand because this is a very bad branding that we did. We will be Stratus Geo soon. We support a broad range of geoscientists. The ISAT2 science team funded us to begin with, and they are a range of researchers across vegetation, bathymetry, oceanography, and cryosphere research. So just as a heads up, that's going to be changing soon. Our name will. We have our own code of conduct because we go beyond the computing that you're going to do within this week. I put this up here so that you can know that the code of conduct is something that we abide by and continue to abide by, and we do take this very seriously, making sure that we have a welcoming and inclusive environment for everyone to do research so that you can do your most outstanding open science. And please make sure to practice empathy and humility. Assume that everyone is doing their best work. Please give and accept and give and gracefully accept feedback. And contact myself. Joanna Milstein is the co-founder for CryoCloud, and Wilson Sawtoff. Our names are down here and emails are down here at the bottom. You're welcome to contact us or any of the PACE leads if you have any issues that come up. Just as kind of intro to why you would care about CryoCloud and doing cloud computing, working in the cloud can accelerate your science and make it easier to do open science. So if you have the right data formats and tooling, you can open data 1 to 2 orders of magnitude faster than you would otherwise. It can make collaboration easier. We'll talk about a lot of these. It eliminates technology bottlenecks. So, when all of us, open up our first environment and have to build that up and put in, pip installs and things like that, it's already available on CryoCloud. It's already been done for you. And data access. So if one person solves the issue of, what's the code snippets to be able to access this code, you can share it with everybody and everyone can use it the same way as you. So it only has to be solved once. And it's easy to use and customizable. So we try and make it look as much like your laptop as possible. The learning outcomes for today is to understand the opportunities and challenges of working in a cloud environment, learn about the general technical tools needed for working in the cloud, and walk through CryoCloud. To get us started, what I'd like all of you to do is to open up the Getting Started survey if you have not already done it. That's going to be this first QR code here. And if you have already done it, please go to the onboarding survey at the bottom. And the way that I'd like all of you to check and make sure that you are all set on this Getting Started survey is to go to hub.cryointhecloud.com, log in using your GitHub credentials. So this is hub.cryointhecloud.com. Click Login to continue. Type in your GitHub username and password and sign in. Authenticate if you need to. This will open here. Leave all the settings as is, and I'll get to these in just a moment. And then click Start. But otherwise, please start filling out that. As long as you can get to this right here, the server options, you're good to go. It means that you have successfully gained access to CryoCloud. So please then just fill out our onboarding survey, and I'll give you a few minutes to do that. All right, how's everyone doing? Everyone done with their onboarding survey? Okay, yeah. Just have, good. Looks like most people are there. I'm going to keep going. All right, so how many of you are familiar with the phrase open science? Most people. As a refresher, it means the principle and practice of making research products and processes available to all, while respecting diverse cultures, security and privacy, and fostering collaboration, reproducibility, and equity. And so NASA and a lot of other federal agencies at this point have stated that science done in a fundamentally more open way is the future, right? So this is the way that we're trying to work, and this is something that CryoCloud is supporting. NASA started the Open Source Science Initiative to really push the idea of open science forward. So the goal for this initiative is to make science more transparent, accessible, inclusive, and reproducible. And then they built the Transformed Open Science Program, TOPS, to kind of push forward that initiative, lower barriers of entry, help make science more equitable through the NASA ecosystem. And they are the group that ended up funding, or one of the groups that ended up funding CryoCloud. But with NASA and the Open Source Science Initiative and the rest of the federal government, as well as 80 academic institutions, decided that 2023 was going to be the year of open science. And they were going to kind of catapult us into the future, like really make a lot of progress towards open science in this first year so that we could really become much more open in the next decade. And as we are aiming towards this more open science world, we can better access open science and better create open science through the cloud. So many of you might be asking what actually is the cloud. So it's a virtual space where you can do all of your computing. It has the servers, your software, all of your tooling, all of your data, all in one place, and it can be customized. And anything that requires internet or a router or something to be able to access it is outside of the cloud. So it's nice as you put everything into one place. But as we have the cloud, the way that we think about our workflows and the way that we do science is going to be very different because costs are really different. So in the cloud, you pay for compute. So the amount of time that you spend doing your compute and analysis on your laptop in the cloud costs money for every hour that you use. And you also pay for data storage. So you aren't paying for your laptop necessarily. You aren't paying for your hard drive or whatever. You're now paying for time that your data sits in this cloud space. You're paying for the compute. So keeping that in mind is really important as you create your new workflows. It really forces us to rethink, how do we not store data? How do we kind of get to the data product without storing anything in between? How do we compute faster? These are the important parts of our workflow that we need to kind of reimagine as we start working in the cloud. And what's really exciting is a lot of these principles and practices that we need to implement because they cost more money in the cloud are actually really useful for our laptops as well. So things that allow us to access data faster, work with data much more easily, all of that is really good for our laptops as well. So these principles are great across the board. Shel Genteman is the lead for the TOPS program at NASA. She and some others put together this paper talking about how the cloud kind of changes the realm of possible questions that we can ask in science, and it allows us to advance science and inclusivity simultaneously. And the way that it does that is kind of enabling us to access compute no matter where we are, no matter what kind of laptop we have or computer. So here, you can process massive amounts of data with a $36 Raspberry Pi. You can do it from a flight. You can do it from your cell phone. So anywhere around the world, if you have any sort of computer and a little bit of internet, you can access this if you have cloud access. And so the cloud kind of becomes this digital watering hole where all of us are sharing this resource of data. And now as we create scalable compute that's right next to it, we can go beyond disciplinary silos. We can access really big data without having to download it, because that's the big thing about the cloud. You don't have to download the data. You can have more participation of diverse communities, and we can ultimately connect with society and impact critical decision making on timelines that we've never been able to do before. So there are proofs of concept for this. A class run by Fernando Perez, who's the founder of Jupyter Projects. He runs a statistics class in Statistics 159 course at Berkeley. And over the course of a semester, undergrads put together a science project. And this is kind of the output. It's a Jupyter book, and that includes a main paper, supporting analysis notebooks, supporting code and tests, and then at the end you can use Binder, which is very much like CryoCloud, but it's ephemeral, and allows people to reproduce what was created. So this is a completely transparent, open science project that was created, a study. Someone can go in and instantly reproduce what you've created, and they've all done this in the cloud, so people have learned how to use the cloud, and they've done it very cheaply. So they teach 50 to 2,000 students per course for $1 to $2 per student per semester. So there are ways to do this very cheaply. Even though it costs to be computing, we can make this manageable and start making things a lot more open. So there's a lot of exciting work we can do in the cloud, and we really need new ways of accessing this and organizational models to be able to do this in our own lives, because it's actually pretty complicated to be able to access the cloud. So CryoCloud came out of the ISAT-2 science team, as I mentioned before. ISAT-2 is a NASA mission. It's a laser altimeter where they measure the surface elevation of the Earth. And in May 2022, we had a science team meeting where the science team talked about trying to transition to the cloud and complained about the fact that there are non-intuitive pricing structures, computing options, and infrastructure. The documentation is crap. It's costly to use. You can actually open up the cloud and ring up a $4,000 bill without really getting much out of it or realizing that you're doing that. And they were struggling because they didn't feel like it was obviously more collaborative or faster. And myself and Joanna Milstein, who was a graduate student at the time, were sitting in the crowd, and we were like, this is not how our experience has been in working in the cloud. What can we do to fix that? And the reason why our experience was different is because we were working in a cloud computing platform that was built by 2I2C, the International Interactive Computing Collaboration. They're a nonprofit service provider that builds these JupyterHubs. They came out of a collaboration between Berkeley, UBC, and Pangeo, if you've heard of them, where they built these JupyterHubs and found them to be super catastrophically successful. Everyone wanted them, so they built this nonprofit to be able to serve research and education as cheaply as possible with these cloud platforms. And everything that they build is contributed back into the Jupyter ecosystem, so it's completely open and reproducible. And so we decided to partner with them to build a cloud computing platform with bumpers. And so the goal was to build a simple and cost-effective managed cloud environment for training and transitioning lots of people like you to cloud workflows and determining community best practices. So I talked about reimagining your workflows. A lot of us, we haven't solved the problem of like what's the best way to store data and access your data and compute. And so we're building those as we go, and we're using feedback from you guys and a lot of the like testing that everyone on our cloud does to be able to build those best practices. And we built this cloud this cloud platform to be able to allow you to process data faster, minimize downloading, and democratize science. CryoCloud is meant to be persistent for at least 3 years. As I mentioned, we're putting in for new funding. You will have access as long as CryoCloud is open. You have access to small server size, which is 32 gigabytes and 4 CPU. That's larger than most of our laptops are, so it should be really valuable for people who need a little bit more. There is an option to bring your own cloud credits to access larger servers. So as you write grants later in your career, if you're a grad student or at any point and you want to access more than 32 gigabytes, you can. We just recommend you put that into your proposals and get cloud credits, and then we can support that. We do new tool development, so cost monitoring, different collaboration tools, all of that goes back into the Jupyter ecosystem. And we take community surveys and get feedback so that we can create the best practices that we need to, and we can grow much more stably. So what you end up getting is here in the middle, you get this cloud platform, you get custom environments, you can bring your own, you can use the ones that are already available because it's pretty flexible. There's online content. Support and services, you will be able to interact with 2I2C on our Slack channel. I'll talk a little bit more about that in a minute. And then all you need is to have your GitHub user ID and password to be able to access it. So it takes us a few seconds just to add you. And the goal is to make a unified experience across your different platforms. So it should look and similar to what you have on your laptop and be pretty intuitive. There is a file management system. Here, there's a full terminal window like you would have on your laptop. You have things like Markdown preview and editing. There's a number of different tools I'll go through in a moment. You have normal computing. There's a virtual laptop or desktop where you can access things like QGIS and the internet without having to move it out of the cloud. And there's a file synchronization tool called SyncThings where you can move data around more easily between your laptop and in the cloud. And then you have a lot of different choices of computer language and server size. So you'll see Python, R, and MATLAB are in there. MATLAB you have to bring your own license for. Hopefully we will have a license soon that will be provided to everybody. But the way that we've gotten around this being an open science platform and also not leaving 30% of our users behind who are MATLAB users is by having MATLAB on there. And then we have this server share where you can choose different sizes. This allows us to cut costs by allowing us to put multiple people onto one computer if they don't need all 32 gigabytes of memory. And what's really nice about CryoCloud is we have different kinds of users in one space. So the people who are developing Xarray, who may be developing some of the tools that may come out of this Hack Week for PACE, all of these developers, Earth Access is also in CryoCloud. They're going to be in the same space. So if you have questions, if you have bugs that come up, what's really nice is they will be able to be in the same space, get those that feedback really quickly, fix the bugs, and then that interaction is probably the most important thing that we have in CryoCloud is that community, kind of right at your fingertips. So let's take a test drive of CryoCloud now. If we're all hub at cryoonthecloud.com, I mentioned the Python server there. Go ahead and keep it to 2 gigabytes of RAM. We found in a study looking at people's usage of the cloud that most people only are using about 2 gigabytes most of the time for their work. And what you can do if most of the developing you're doing is like just coding and you actually aren't running things, you can shut down the server, open it back up, and then have it like choose a larger server and then use that larger amount for a shorter amount of time. You don't have to do that. We have pretty good cost savings, but like that is one way that you can cost save in the cloud. There's also this Pace Hack Week environment that you can access for a lot of the tutorials, and I'll talk about that in a little bit. And then there's Bring Your Own Image. I can show you here, book.cryo in the cloud.com. If you go to CryoCloud best practices, this will be like your friend, like one of the most important things that you can continue to look at over time. But if you scroll down to the bottom, you can see what examples of tags look like that are already built that you can access if the ones that we have don't work for you. The ones we have between the Pace Hack Week and CryoCloud should work for you for most of your needs, but if you want something else, this is going to be your resource for inputting those into this Bring Your Own Image. So that allows you to flexibly choose. This is a new tool. Before you were stuck with whatever default we gave you, so this is really nice. And then there's also, this is a GPU at the bottom. Some people may use that for one of the tutorials later, mostly used for machine learning. So if you open this up, how many people have used JupyterLab before? Sweet. Jupyter Notebooks, everybody, yeah. How many people have used the JupyterHub before? Sweet. So JupyterHub is just the cloud version of JupyterLab, basically. There's a few, like some changes to it, but it's pretty much the same if you're familiar with that. I'm going to give, for anyone who hasn't been on this JupyterHub, just kind of a run through of kind of what you can find in here. You will notice that as I open this up, there are a number of notebooks that are already open. It saves your place as long as you log out and close your tab. The next time you open, it will look like what you left it as. The left-hand side here, this folder is going to be your file browser. You can see I have a number of files here. All of this is your personal file storage, and it doesn't change. Other people cannot see it. The only thing that people can see are shared public, which all of you can open and write to, and to shared, which you can only open and view things from. You cannot write to unless you're an admin. So shared public, the big thing here with shared public. Some of you may have accidentally put a lot of data onto CryoCloud and we'll send you a message and say, please delete things. Please don't delete things out of shared public because there's a lot of people who use that for their own work and you would be deleting somebody else's work. So shared public is a very sacred place that we need to be careful about not deleting everything unless it's our own work. So that's a big disclaimer there. The rest of this, you'll be able to play with. One thing that's cool in here is you can add favorites. If you have a folder that you want to access really easily, you can just click favorites there and I can remove it there. So you can navigate this like a normal file system. The plus here is going to be your launcher. This is where you can navigate to all of your tools. This opens up a new notebook, just like this, creates it. The virtual desktop. This is a really cool tool, like I mentioned before. You basically have what's like your laptop. It's a Linux desktop. You can open something like QGIS. So say you created an image. Now you want to visualize it. You don't want to download it onto your computer out of the cloud. So you just use QGIS to open that. There's also an internet browser down here at the bottom. And you can navigate all of your like all of the file system that we were just looking at is all right here. And so that opens up a new tab. Sync thing, as I mentioned, is how you can share data pretty easily between your laptop, other hubs, and CryoCloud, and there is documentation down here for how to set that up. VS Code is a really nice program for being able to develop code if you don't want to do it in a notebook. There are some co-coding tools in there that you can use, but this is VS Code. The console is really nice. If you have code that you want to just kind of test in a separate kernel, you can. Oops, that's not what I meant to do. You can move all of these panels around, so I can take it and put them side by side if you want to look at notebooks side by side. The console will run one line at a time, so you can test everything that you'd like there. You can create a new file directory, upload. This opens up my computer's file system here from my actual personal laptop. The other thing is if I have, just your Finder or whatever from your laptop with your files, you can just drop them into here. As long you just hover them over this and it'll drop in. It does take a little bit longer to upload into CryoCloud, so just keep in mind files take a second. And you have a little Git clone thing here. There are a number of ways of interacting with Git. On CryoCloud, here's one of them for clone repository. In the launcher, you also have a terminal, which runs your command line, ways of making markdown, .py files, that sort of thing. And Mist Markdown is a really nice, rich texting documentation sort of thing that we have downloaded, or that we have installed in CryoCloud that allows you to create some of the cool features that you'll see in some of the tutorials and things, where you can hover over like a reference and it'll like open up the preview to that just by hovering over it. You can interact with figures within a tutorial notebook, things like that. That's what Mist enables. Over here on the left-hand side, this is going to show you all of your tabs open. Kernels are like essentially each of these notebooks has a kernel open, a Python kernel open. You can shut all of them down here if you want. When you close one of these notebooks, it doesn't actually release that from memory / shut down the kernel, so you have to do that yourself if you are trying to save memory for some reason. You can do that here. You can also do that up here. Dashboard is a place. Dask is a way of parallelizing your work. I actually have an example of this in here. I'll move on to this first. This button down here shows you an outline of the notebook that you're looking at. So it's nice for navigating through a notebook like mine that is 1,000,000 pages long. So I can go to workers where my Dask is open, and this Dask dashboard is right here. I copy and paste that into here, and I can see what workers are doing, where the data is being moved around a bunch of different computers as they're being worked on in a parallel way. So this is a really nice functionality to have. Here, this is another way of interacting with Git. You can open the file browser, initialize a repository, and clone. Another cool thing here is any Jupyter extension that you might like. We don't have to install it into our actual environment. You can do it here through this little plugin. And one of the things that off and on works but is really nice is Jupyter Collaboration. So I have instructions on our Jupyter book on how to use Jupyter Collaboration. It's basically co-coding. You can give a link to somebody for them to access the notebook that you're working on, and then you can see where they're working and where you're working, and so it's really nice for teaching. with other students or with your advisor. It's nice to be able to co-code that way. The current version is a little buggy, so it's not working right now. I won't demonstrate it, but off and on it works. And I do have instructions to make it work. And I'll keep posting on our Slack channel if we have an environment that is functioning for this. But basically what you do for any sort of extension is you can get the documentation by clicking here, or you can click install, and then you'll get a pop-up that says you want to refresh your page, and you'll want to go up to this refresh here, press refresh, and then it'll be installed when this refreshes. Another thing that we have is Jupyter AI. This will be functioning tomorrow, as this one got out of date in our environment, but it's a way of using something like ChatGPT interactively in your notebook, and you can interact with some of the Jupyter functionality to be able to do that. That's installed, and there are instructions online for how to access that. Over here on the right, this just gives you information about the metadata for your notebooks. This gives you kernel usage and memory. One thing to keep track of that's really important is along here on the bottom in your notebook, this tells you how much memory you have and how much memory you've used. And this is really important because we opened up 2 gigabytes of RAM, and we are now using about 1 gigabyte. And so as you get close to this number on the bottom, it will turn red, and then your kernel will crash when you go over. That just means that you can rerun everything if you want to stay on the same server, but if you do that, that might mean you might need a larger server. So you log out, and then you come back in with a little bit more memory, and then you can start working again. So that's an important thing to keep track of if you start having any issues. And then we also have a debugger over here on the right side. Help gives you all your resources that you might need. The nice thing in settings that you might find useful is theme. You can change your look to dark if you like, or keep it at light. You can also change all of your text sizes, or sorry, font sizes. Tabs, I don't really use. You can move around your tabs. Another way of interacting with Git. Kernel, this is really important. If something freezes, you can go shut down your kernel here and then restart it. You can use restart interrupt kernel. It's like pushing the stop button here. Run has a bunch of things that are running your cells like you would in a normal notebook. If you go through that. Important things to find in file. Sometimes like saving a YAML file will be in here. You can save your notebooks. The most important thing that you'll find here is the hub control panel. So unlike normal things where when you're done you want to log out, actually in CryoCloud what you want to do is you want to go to the hub control panel and push stop my server here. So what normally happens when you log out is the server continues running for 90 minutes until it's inactive. And that is to protect us from having your computer continue running indefinitely. If you are inactive, the server will shut down after 90 minutes. But we are paying for that compute while that's still running. So the way that you can shut it down immediately is to go to File, come over here to the hub, whatever it just was, the thing that I clicked, and then stop my server. And then once stop my server is done, you'll go over here to the right and log out. And then every time make it a practice to close that tab, because things just get wonky if you try and re-enter CryoCloud from the same tab. So that's going to be your friend, Hub Control Panel. Let me change my settings so you can see this more easily. All right, so the thing to keep in mind is, actually, I'll log out. Is it okay if I have 5 more minutes?
Yeah, if you want to go to 11, feel free.
Okay. So you'll see once I shut this down, the kernel died unexpectedly, just close that out. And now I'm going to open up the hub again. You don't have to follow along with this. I'll just show you what the Pace Hack Week image looks like really quickly because it's a little bit different. Does anyone have any questions so far? Mm-hmm.
When you log into the default one, is that like a free platform, or is like Pace Hack Week paying for that too?
So CryoCloud is paying for all of it. There's nothing that's free in the cloud, but it's pretty inexpensive for a small computer. So when you, stupid thing, when you use something that's a computer that's really small in the cloud, it's cents, right? To be able to access that, if that, like it might be a cent per hour or something, but when you start to use larger computer sizes, which we don't have access to, or we don't provide access to on CryoCloud, the cost goes up exponentially. So the larger computer that you have, the faster, the less you want to use it, right? The more you have to worry about costs, because it'll be like $2 an hour instead of, a cent per hour or something. So don't worry about the costs, other than the best practices in working in the cloud is shutting down the computer when you can. But this is all on the CryoCloud dime. So we are finding the cloud credit, we are finding money for the cloud credits. It all comes from the same pot, no matter what computer you choose on CryoCloud. So the main difference you'll notice, all of my notebooks popped up the same way that they did, even though we're now using a different environment. There's different Python packages that are available to me now. And you'll notice my launcher looks different. So now we have this bash tool, and we have the VS Code, but we no longer have the desktop because that's not installed in it. And so depending on what environment you want, what tools you want access to, will change which one you choose or input into. And so there's a lot of flexibility. You can build your own environment. We can teach you how to do that. But yeah, there's flexibility in that. So going back to the PowerPoint here. Housekeeping. So one of the main things I mentioned is it costs to store data. So we give a limitation for all of our users, keep it to less than 10 gigabytes of data that you store in the cloud. There are lots of ways where you can temporarily download and then delete, and that's perfect. That's the best workflow that you can have. Long-term storage we do allow, but try and keep it to less than 10 gigabytes, and if you need more, come talk to us because we can work with you. It costs about $90 a month to store 2 terabytes of data. And if we want to support something larger where people are storing more data, we just have to apply for more cloud credits or find those somewhere. When deleting, as I mentioned, don't delete out of shared public unless it's yours. Pip installs. So some packages are not available in our environment that you may want to use. The proper practice for installing these is at the top of your notebook, type in %pip install and then your package. So not just pip install. The %pip install puts it in the proper place for the kernel that you're using in that notebook. And by having it at the top of your notebook, you make it reproducible for anyone else using CryoCloud. When you send that notebook to someone else, they know to install at the very top, and then they have the same exact environment as you. You can also, because those pip installs are only ephemeral, you have to do that every time you open up the cloud. You can make them not ephemeral and to last by going to this Python installation how-to that we have in our Jupyter book, and it'll tell you how to make something persistent. So clicking on that, down here at the bottom, you can create your own kernel that does stay persistent. Otherwise, they clear out every time, and you have to pip install each time that you get back onto CryoCloud. And then the last thing is, as I mentioned before, Hub will stay open for 90 minutes if you forget to turn it off, of no use. And please use the stop server when you're done. Troubleshooting, you can go to our Slack channel and go to Hub User Questions. Hub User Questions. That's the main place to ask anything about your data, about how to access things, about tools, and one of us will help you. This will be a place beyond the Hack Week where you can continue to ask questions. You can report issues in our image, like say we go to Jupyter AI, that thing that I clicked on and it's broken. You can report that either in our Slack or in our GitHub. Pangeo Discourse is a place to ask questions if you want, and then if all else fails and you don't know where to go, contact myself or this CryoCloud at minds.edu, and one of us will be able to point you in the right direction. One important thing for us, and something that sometimes gets lost in the weeds, is citing CryoCloud is really important, right? We're paying money from grants to use CryoCloud, and so we would love it if you produce science or make an AGU abstract or something like that to cite CryoCloud in your paper. And if you'd like, in your acknowledgments, you can acknowledge our grants, which I have all of this on our Jupyter book. Right above here, citing CryoCloud. Those instructions, our grant numbers are right here. This does cost money, and it is part of your methods. So when you are producing science, the fact that you produce this in the cloud is a really important piece of your methods. So you can cite CryoCloud in that way. And then cheat sheet, here's all the links if you need to access them to our website, our hub, our Jupyter book, our GitHub. All of basically anything you need to reproduce CryoCloud is in our GitHub. And we have a Zoto CryoCloud community. You are welcome if you create content that might be cool to put in our Zenodo community. I put CryoCloud presentations in there, things like that. You can put that in. We can put that in there. If you want more skills, there's other Hack Week Jupyter books outside of this Hack Week. We have tutorials in CryoCloud to be able to access different kinds of data. And the NASA OpenScapes Cookbook is a great resource for accessing data in the cloud. And then last two slides. Kind of the fun things for working in the cloud are there's some really cool functionalities that you have. So magic commands are things that are really cool. They are the percent sign in front of a few different kinds of magic commands. So say matplotlib widget makes interactive plotting throughout your notebook. That's a really cool tool to have. It makes everything look nicer, and you can interact with it, zoom in and zoom out of your plots, things like that. Percent auto reload, that means that if you change the library that's been loaded in your imports, it'll automatically update it. Percent time, if you want to know how fast your cell runs, use that and it'll tell you how fast it goes. So if you want to compare one function to another, you can use that. Something else that's really important in notebooks, putting a exclamation point at the beginning of your code turns that cell basically into terminal. So it'll be like, if you want to change directories like you would in terminal and say cd blah, 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 you just put a percent or an exclamation point in front of it, and it'll act like it's terminal. And there are shortcuts in Jupyter for creating, like moving from cell to cell, from running cells, copying and pasting. These are found here. You can use them. So thank you very much. Let me know what questions you have. And I'll be around. You can ask me questions all this week, most of Thursday, but not all of Thursday. The slideshow is available to you, so you can look back to it at any time to get that information again. Does anyone have any questions? Yes. Let's start here. Jackie.
The GPU option doesn't look like it's accessible, and is that like?
It's a special request. For people who will be doing some of the machine learning work, we will make sure that people have access to the GPU. The GPU is a little bit more expensive, so we don't just provide it across the board, but we do have it available for like machine learning needs. When people have them, you can request them. And that just, we go into our GitHub and change some of the teams that you're available or that you're a part of, and that just changes what computing you have access to. Yes, Eli.
So what's the motivation with the name change?
We just were improperly branded. I mean, CryoCloud's a great name, and a lot of us are cryosphere researchers, but the ISAT2 science team isn't even just cryo itself, and like they're one of our main funders. So Stratus Geo will be a geoscience platform. And we were running into issues. I mean, yeah, I love the name, but we were running into issues where people like, I'm not a cryosphere researcher, and people not feeling like they belong, right, because of that, and we want to avoid that. Everyone we have on is meant to be there and to stay there. And it's really nice to have like multiple disciplines in one space, right? How many of us just do oceanography or like just work with oceanographers, right? Like I work with a large range of people, and so being able to collaborate with all of them is really important. Yes.
So I remember the advice used to be to not mix your pip and your conda environments, and you're suggesting pip install. I feel like the advice has changed to just, they work better together now, so go ahead and pip install into your conda environment. Is that what you guys are experiencing?
I mean, because it's ephemeral, it's fine. Okay. Yeah. I'm not sure if it's working yet. Mamba might be working. For anyone not familiar, so pip install is like the more basic version. Conda thinks about all of the compatibilities a little bit more. And then how many people are familiar with Mamba? Mamba's just like a way better version of Conda. So if you want to solve an environment, it's intuitive, it's a million times faster. Use Conda or use Mamba as much as you can for solving things. And I think there might be a % Mamba install soon, or already is.
Also, you have updated to the version of Conda that now uses Mamba as the solver on the back end.
Cool.
Yeah, so you're good on that.
We're good on that. So you can use % Mamba install. Or whatever, yeah, it's fine. If it works and you make it reproducible by putting % pip install at the top of your notebook, it's ephemeral. You aren't gonna mess up your environment for the rest of time. If you do it, if it messes something up, just shut it down and come back, and it's fine. That's the nice thing about it. You don't break it permanently. Cool. Break for 2 minutes.